Hello, everybody. I guess it's, I could start, right? It would be the right time. Well, then, thank you, everybody, for coming here. I hope you're having fun so far. I think I haven't been in Berlin for 3 or 4 years, so it's nice to be back again here. And today I'll be talking about libraries for Kotlin native citizens. Just very shortly about me, I'm a freelance developer from Spain, as you can probably easily guess from my accent, sort of living in Germany now. I'm a member of the Google Developer Expert Crew. I'm the Kotlin Weekly publisher. So if you want any stickers, just feel free to come later, because I have a fucking ton of them and I don't know what to do with them anymore. This is my Twitter account, so you can, if you want to ask me anything, just ping me there anytime. And the main things I do right now are working with Kotlin and Android, backend and Kotlin, and iOS, most of it Swift. I'm obviously trying to push it into the Kotlin native direction, but it's not as easy as one could initially think. Now that you know a little bit about me, I would like to know more about you. It would probably be stupid if I asked how many people develop here with Android, but how many people here develop with Kotlin native? Or has some practical experience with Kotlin native? Okay. I hope you can learn something today that you didn't know before. That would be the best output for this session, I could imagine. So now, when we're talking about Kotlin native, or in general, when we're talking about multi-platform development, what is the main motivation? One could argue that what we want when we are jumping into the multi-platform development is to reduce cost. In general, I think that's a very bad approach. If you're justifying things just because they are cheaper, you're probably going down the rabbit hole. I generally prefer to talk about increasing the quality. When you are going into a multi-platform solution, you will have a single code base that is easier to tackle, is easier to know. You will have the bugs more centralized in one place rather than having 3 or whatever different systems that need to connect. And I think that leads you into a better place. I'm adopting the multi-platform solution, not because it's cheaper, but because it gives me more quality and I can reach a better place. It leads into some interesting positions, such as sharing code within the company in a different format. If you're working as a developer, you probably have some sort of multi-function kit library that you use in several applications in your company that Ruye use, that maybe you host their things like common calls to a web service or some common UI or whatever you need to do. Imagine this would be centralized for all your different platforms instead of having different multi-mobile kits or however you want to call them. And it pushes you in a very interesting scenario as well. You could have, instead of a team that is working on your iOS app, a team that is working on your Android app, you could focus on feature teams. That is, you get experts into the payment systems, you get experts into the login system, into the whatever module you have in your application. Regardless of not regardless of the technology. In this case, would be Kotlin native or whatever technology you're using, but you allow to make the knowledge more deeper into a particular domain. And you focus on one technology stack. It is well known that finding developers is not the easier task in some places. If you could strictly focus on one technology, it might make your life better. Now, what is the current state of the multi-platform development? We always had things such as the platform proprietary solutions, Xcode or Java or Kotlin or whatever we are getting from Google or Apple. And a few more paradigms are available. There is this one that has been there for a while of using hybrid HTML applications with some JavaScript frameworks, using PhoneGap or Cordova, for example. The main counter-argument for this paradigm is that those frameworks are not as efficient. They generally cannot access the hardware as efficiently as the native solution is doing, etc. I found an interesting argument, and it is that at some point in time, probably still now, it's easier to find JavaScript developers than Swift developers. So I've heard of some companies that jump into this technology because for them it's much easier to bring developers, start creating whatever solution they want to create, rather than spending 3+ months trying to find a developer that is available. And we have also the sort of cross-platform native solutions such as Xamarin, React, etc., that are a little bit different from these hybrid HTML applications. I think the hybrid HTML, they had traditionally some sort of argument that could be used in some applications where some components are module, they could be web-based, and maybe we don't have the high-performant module such as a map that is downloading some information from the internet and displaying it as pins, but maybe some form where you just have to input some data, that could make sense. The cross-platform native solution is a bit different. It's generally tackled to one particular framework or platform, such as Xamarin, which had another set of problems. Xamarin was, it has been a proprietary solution. I think the price a few years ago was not low. It was probably on the order of a few thousand euros, which it could be a deterrent for some companies that are willing to adopt it and start working with it. So why Kotlin came into play here? Kotlin is a modern language. It's compared with Java, the first Java version was released in 1995, which in terms of computer science is something prehistoric. They had a lot of problems, such as releases that take forever until they are on the air, some problems with licensing, some releases that have a very short life period and then they disappear and have a different license, etc. And that was a pain in the ass for some big actors in our world, namely Google with Android. Then there was this additional problem, little problem, of Google relying on the official, on the Java framework. Oracle acquired Java essentially to sue every other player in the world. Oracle right now has more lawyers than developers. It's like this. It's not anymore a software engineering company. It's a company that acquires company and sues other companies, and they make money based on that. There are different business models. Some companies sell food, some develop software. You have Oracle. And that was probably pushing some actors into, well, we can't rely into basing our platform, namely Android, into Java. Now, Kotlin has a few nice features, such as the interoperability. Kotlin can talk very easily with Java. We even have, if you are Android developers, there is this beautiful Kotlin transformer that can transform code more or less all right from Java to Kotlin that you can use later. They have a lot of community support, which is something basic. You might see in another frameworks, I don't want to name Flutter, but things like Flutter might not have as much community support in the shape of libraries or software that has a decent side that has been developed for many years, and it's nowadays used in many enterprise applications. Kotlin is part of JetBrains, which has a top-notch tooling. There is even this thing that Xcode, until Xcode is from Apple, Swift is from Apple, and until very recently, Xcode could not refactor Swift. Both of them being from the same family, whereas AppCode was able to refactor Swift. So it's a company that they know how to do software, and they know it well. And a good thing with the multi-platform solution is that sharing is optional, and it does not need to involve the entire application. You might want to commit just to a certain module of what you are developing, to some portion of your software, but you don't need to sell the entire product to this technology, which is something very useful. You don't need to jump into Kotlin native and say, that's the only thing I need to use. You just can do small modules that are fitting within your schema and your development process. This is the current situation. The latest version, 0.9.3, still beta, was released in the last quarter of the last year at the Kotlin Conf. I think there was some sort of expectations that were never met, because most of the people was expecting a final version that was stable, but that didn't happen. We are in the second quarter of 2019. Not sure whether that will happen at any time soon or not, but it's very likely. For being a beta version is becoming more and more mature. And well, this version 0.9.3 included already the coroutines for Kotlin native. Before we move into Kotlin native, JetBrains came with the idea of let's gonna have Kotlin anywhere. The idea is that the code that is being developed for the server could deploy for Android and the browser. It's still quite limited. There were no POSIX architecture. Two big players, Android and the browser, but that was the initial idea, the primigenial embryo from Kotlin native today. It works like this. You will have a common module that defines the functionality that will be implemented into the native modules that you will be dealing with. We will have a GBM module that compiles for things such as Android, the native one that could compile, in our case, as mobile developers into iOS. We will have also a GS module that it's not exactly compile, it's transpile, but essentially generate codes that we can access from GS. And for the iOS developer, it would work as this. You will have an iOS framework that your iOS developer will access to. And for the Android developer, you will generate a library that can be accessed from your Android application. So what is the principle of this? Well, the idea is that we should not use Kotlin native for UI. And there is an explanation for this. Google doesn't care about the iOS UI, and Apple doesn't care about Android UI. And they're essentially different. We will have an action bar on Android or whatever component that is essentially different from the one we have in iOS. It would be a mess to create something that needs to be compiled in such a different platform. So UI is a mess. But if we think under the UI, the applications do exactly the same thing. They connect to an endpoint, they connect to a web service, they download some JSON information or XML, whatever. You parse this information, process it, and store it in a database. Those are things that are essentially the same in each app and are easy to normalize. A little bit more technical. Kotlin native uses LLVM. LLVM is this collection of modular compiler and toolchain technologies developed initially by Chris Latner, the creator of Swift. It uses the version 5.0 particularly, provides some runtime warranties such as exceptions and memory management, and can interoperate with C and Objective-C or Swift in this case. There are some platform libraries, so we can compile into things such as any sort of POSIX architecture, Apple frameworks, Win32, so we can end up with a .exe file that compiles for Windows, DOM, etc. Conceptually, it's probably very easy to understand. We have a KT file with our Kotlin code. This goes through the Kotlin compiler into an intermediate representation that is being sent to the LLVM compiler and creates the platform binary that we want. Now, the compiler, a little bit more about it. It serves frontend with Kotlin JVM and the Kotlin JS. It's finally written in Java and Kotlin, not sure why, and produces bit code via the API from the LLVM. It has a few peculiarities. The memory management is uses an ARC with a cycle collector. So if you've been developing with Objective-C and iOS, you probably know the ARC. Essentially, in every cycle of the machine, checks that there are no dead references and try to remove them when something is in memory to avoid memory leaks and memory getting too big. When we're working with pure Kotlin, however, we don't need to worry about memory management. This is done automatically. As much as you don't have to worry, you obviously need to know what's happening under the hood in order to avoid memory leaks or other sort of problems. There are things such as weak references supported. We can use them. And the memory sharing model, it's a bit different. So different threads can have these joint object graphs, and those can be transferred between threads. But we need to make, in order to do this, we need to make sort of a super immutable object. That means when an object is going to be transferred between threads, we need to call a special operation called frozen. Essentially, frozen will make this object a super immutable thing with all the references, the entire tree, and at this moment that can be transferred. I think it removes some problems from the equation and adds some problems. Which it's something that probably each person has a different opinion. I think it's an interesting concept to know, nonetheless. It has provides interoperability with Objective-C, C, and Swift, and the other way around. Not with C++, which is not a surprise because C++ cannot work with C++, so nothing new on the zip. Kotlin can call all those languages. We can extend Objective-C classes, for example, and the memory management is aware of what the Objective-C runtime is doing. How is the mapping done? It's probably easy to guess. Numbers are kept in their particular format, so what is a float is a float, what is a double is a double. The strings are converted into the target technology. The Kotlin declarations wrapped in CNTTs are generated automatically, and there is generally an equivalent object in the object-oriented paradigm. So classes will be classes between Objective-C and Kotlin. Blocks are lambdas, they're transformed, and it can be compiled into a framework that will be used into our mobile app. Now, JetBrains was so nice to offer us something also called Kotlin library, and it's a way of packing and holding a collection of code and metadata that we can share among our application. This will have a format called extension called KLIF. It holds all the metadata and the big code already compiled, so similar to a jar file, nothing new. And we have some tools for creating and storing libraries in repositories. Ideally, at some point, we might want to have something like a Maven repository where we upload our Kotlin library and it's reused in our organization or wherever we want. Now, in order to get started, you can download the compiled version, you can compile it by yourself. In order to do that, you would need to clone this repository, you would need to update the dependencies, and bundle the entire package. If you want to work on a plane and you haven't done it before, I recommend you to actually call the bundle before jumping into any plane, because that can take a significant amount of time. And we would call something like this. We will use the Kotlin C native in order to generate the binary file. I'm going to make just a super short demonstration on how that can be done. So we have, for example, this file here, which is it's very easy. It's just a hello world in Kotlin, nothing very special. So how would we compile this? We would call this function from here. We can specify the output if we want, and well, a few more options. Can you see any problem at first? It takes a fucking lot of time to do it. So it's not particularly fast. I think JetBrains came with the approach of, which I think is fair enough. Let's gonna first make this work, and then later we can work on optimizing it. It makes sense, because otherwise you are doing some early optimization and it will never work. And if we execute now the generated file, we will have here exactly the hello world. So super easy, something you can do with any other compiler. And yeah, how this works regarding the code. So we will be playing with the keywords expect and actual. The expect declaration this will happen in the common module. It marks what will be later on implemented into the particular modules of the technology. They never contain any implementation code, they're just the definition. And the counterpart in the particular modules, in the native modules, they need to have exactly the same fully qualified name, otherwise it doesn't work. So this is how the actual would work. We specified actual in front of the class. This must match exactly the signature that was on the original, on the expected package, and we provide the implementation we want. This is a full example. It's probably easier if you see how this works in a practical example, so something like login on the screen. That's something that we always need to have. We always download any library that helps us with login. And login is different, right? If we do it in Android, we call the print line. If we do it in the Java, we print on the console, etc. So we would end up having something like this, a few functions to print our log, and some log level. Depending on that, we can take one option or a different one. So this would work like this in, for example, Android. We will have the function write log message that calls to print line and prints whatever we want. And in JavaScript, it will be something like it follows here. We could iterate over the log level, and based on that, we will get a console object and log it as we would do it with any JavaScript application. Now, there are a few actors when it comes about libraries that are in play here. JetBrains is obvious, is their technology. They're trying to push a lot of libraries that use it. And two interesting actors are here, Touchlab and Square. Square is probably this company you know. They've been doing a lot of open source code. And Touchlab, it's an interesting agency based in New York that they're playing a lot with Kotlin native. Kevin Galligan, the CEO of this company, has been contributing to the Kotlin language itself. He submitted a fix that I will show later, fixing generics for Kotlin native, as well as a few open source libraries on the hood. There is, however, and even if I'm talking about this, the current status is not that stable. So you will find some libraries that are still beta or are not yet fully stable. But still, as developers, it's good to see what's coming and keep it into consideration. Some of the community projects that you will find are SQLDelight and ArcDB that are having, both of them have been deprecated, and there is another library called SQL Lager, like the beer. There is multi-platform settings, Stately, OKO2 from Square that is under development, and a few native libraries from JetBrains. Kitor, in English Kitor, in German Kator, which is client-server networking. The native part right now is the client, not the server, though. Coroutines, all of you know them by now. Kotlin X IO for input-output operations, and Atomic Foo for atomic operations. So Kator, it's a web application framework. It provides us both the client and the server. The server is very simplistic. You can set up a server quite fast using Kator. Provides a DCL for web apps and can be used obviously on web, iOS, and Android. And provides a unified toolset similar to Node.js, but with build concurrency and type safety. How would you start using it? You would need to include something like this on your build. And I actually see that there is a different one if you want to use iOS or Android. You just would need to change the package on the client module. And later on, you will have something like this. On the common module, you could have something called Application API. This is something that will be accessible to the all the submodules. Here you could define, for example, something that connects to a URL specified here and creates a coroutine and gives later, I don't know, whatever, reads this URL and provides us with the information found there. And this is how it would be found on Android. Imagine we want to get information from this endpoint or from this web service and paint this into our application in any text view or in any view that we have there. In the case of Android, we will call to this find view by ID to get the particular view we want, and we will set the content view there, whatever we want to operate. In JavaScript, for example, it would be a bit different because in JavaScript we don't have text views. Instead, we will have an object called document that can create whatever HTML tags we want, or can access them from the screen and can write them over there. This would be the particular specification. Coroutines, probably all of you know them by now, is the async response of JetBrains. They actually have one particularity in Kotlin native, and it's that they are single-threaded. They don't support any multi-threading. It's something that there is an issue open in GitHub to at some point solve it, but no idea when this will happen. Again, we have a common module for a common library of coroutines for our common module, and one for the native implementation. Very easy example as well on how it would work. We would have on the common file, we would write this hello coroutine file that later on this actual.kt would be the actual implementation that we will be having on iOS or Android, and then we can operate as we want. Later on, we will need to call, as you can see downstairs, as you can see totally down, the name of the file, KT, with a camel case, and then we will be able to access any function that is public in that file. Kotlin X IO is the library for IO primitives buildings and manipulation, and is still experimental. If you're trying by now, you're thinking like, there are so many experimental things on Kotlin native. You're so right. It's probably that that thing that will prevent you to jump full into Kotlin native, but still, I believe that for certain experiments make a lot of sense. Same package to call here in this case will be for the GBN machine. And here is very straightforward to use. We will have an object called byte read packet that is a managed sequence of buffer views. Is read only. This would be to do read operations. There is no way to reset or push back when you have already read the bytes there. And when it becomes empty, it will be automatically released. Obviously, if it's an input-output operation, we also need to write. So in this case, we will have the object byte packet builder, which is the object we will use to actually write. It has to call explicitly release in order to discard all the bytes, otherwise we might end up falling into a memory leak. And when we call build, we essentially make an instance of byte read packet and start operating with it. We can see it when inside the while, the second line, that's where we reset actually and start writing with this object. Atomic FU is the library for atomic operations in Kotlin. Another thing about Kotlin, there are Kotlin native. There are no threading primitives, such as synchronize or volatile. Those are the keywords you're very used to in Java. JetBrains actually recommend to use atomic FU instead. It might be a change of paradigm for all of you Java developers. And again, we need to include the line here. This library particularly is very experimental. They have the current version is not 1.0. It supports a few basic operations, doesn't get too complex at it. So it will work like this. We will declare a top variable in the upper image for a log-free stack implementation. And down we can see that we can perform a volatile read or a volatile write with this variable. And we have a couple of functions more. We could have, for example, the function updates that provide us a lambda or update and get or get an update. And this is sort of a more idiomatic log-free code. We can operate with this value in this way. And log-free, as I said. So there is, this is the way we're solving the concurrency. SQLiter and SQLagger, narc.db was deprecated at some point, and this is the natural evolution from Touchlab, this company I have mentioned. SQLiter is a very low-level library. You can do dangerous things. So SQLagger is probably the thing that most of us want to use in our standard and not very crazy software. It works very easily. We need to hold an instance of database instance, as in this example, and there are 4 basic interactions. We can do insert, update, delete, execute, and select. If we need any binding, you can do it using a lambda, as in this example. We will kind of specify the parameters that we want to send, a long or a string, and that will be passed to the SQL query. Selects, they do not return a result set, as happens in many other ORMs or database mechanisms. The official explanation from Touchlab is that they are doing this to avoid leaking SQLite statements, and instead what they do is provide a lambda with an iterator. Here we can see that we would receive an IT iterator from all the objects that result from the SQL query, and then we could operate with them and do whatever we want to do. Then we have last something called multi-platform settings. It's similar to the SER preferences in Android and the NS user defaults on iOS. Yeah, it's actually developed by, it's one of those other examples. So this is not supported by any big company. It's Russ Wolf, a person that uploaded this software. Version 0.2, but however, to make something that has multi-platform, you probably don't need to get that complex on it, so I don't think it will increase much more the versions. And it's very straightforward. You will get something like a settings object where you can put content and read the content, store it between executions of your Android and iOS application, etc. And finally, the Kotlin X serialization. What do we do without any sort of serialization? Well, this library is sort of well developed, I think, and it uses a JSON object that allows us to JSON-fy or stringify is called here, any sort of data that we pass. This is obviously very interesting when you have you're developing in the case of Android, it's very common that you need to serialize data to be passed between different components, etc. If you want to do it natively, that would be probably the library you would be using. Now, some considerations in state when using Kotlin native. An object belongs to one thread. Who's happy about this? Is anybody happy? I think it's something very different. It's like when Kotlin says that all the classes are closed by default and you need to specify the open keyword in order to make them open. It's something that maybe because we came from this other background, at least at the beginning is shocking, but it's how it works. Now, what you need to do, as I specified before, is to freeze the object in order to share it between threads. And you might think, what's freezing an object? Did I do this before? Do I know this concept? Essentially, freezing an object makes a super immutable object. It cannot be changed. No reference can be changed. So I think in order to understand this better, you can think that anything you have written until now is not frozen. So it's something that you will start doing from now on. Another consideration into state, Kotlin native can verify safe mutability in runtime. There are obviously a few problems that Kotlin native today is not solving or has solved very recently. Think of this class. This would be a login view model. We have a username and a password. They use a generic, specifying a subject that generifies from a string. That's something common that we can have in any of our code. So until very recently, if we were trying to use this model from this login view model in Swift, we will be getting this error. There was no support for generics, which is sort of the first thing you start doing when you're developing software. It's very easy to end up using them. And this was actually fixed or merged into Kotlin almost a month ago by Kevin Galligan, the CEO from Touchlab, which is really good. It's something that the language needed. I think we also need to understand this thing that if the language just have support for generics, there are probably other things that I will at some point hit that will prevent me from keep developing my software. There is still not support for multi-threaded coroutines. There is an open issue in GitHub. You can go there. There is some people discussing this issue and how it can be solved, etc. It will get eventually solved and sorted out, but this is the situation right now. Also, iOS devs, this is the droidCon. Most of you are Android developers, and we are all excited about Kotlin because it's officially supported by Android, and Google is doing a lot of effort to push it into the platform. What about iOS developers? If you are developing ideally with Kotlin native, you would like to compile for iOS, for the web, potentially, etc. If you go to an iOS developer and tell them that, well, maybe now we need to start developing whatever component in Kotlin, they're probably not going to be as excited as an Android developer, because for them obviously means switching the technology, and maybe they don't have any reason for that. So what's the future? It's very hard to make predictions. It's impossible to make them predictions, in fact. I read this quote here down in, there was a guy that wrote a post called How to be a Developer After 40. He's like 42 or 43, Adrian Kowalewski from Switzerland. And he says that he doesn't know what will happen in 10 years, but there are things that are sure. People will keep asking in Stack Overflow how to solve a regular expression, and there will be another JavaScript framework, maybe Angular 10 or 12 or something like that. And in this post, actually, it's very interesting. He argues that in software, problems keep to be there all the time, and we just find the same ways over and over to solve them. Also, one thing that happens a lot with those multi-platform frameworks is that generally we don't load the Hello World app. That does something very easy. It's very nice. The Kotlab is very well explained. From Flutter, it's amazing. You can do it in 30 minutes. But in real projects, at some point, the complexity starts increasing. And I tend to see that those platforms don't scale that well with the complexity for a variety of reasons. They might not have this support around them of the community, or they're just not thought for projects that can increase in complexity, whereas the native solution generally handles this much better. So obviously some of you might be thinking, well, what about Flutter? How it compares with Kotlin native? Can they work together? Can they operate? Well, I'm not an expert on Flutter. What I believe is that Flutter has done a very good job and creating custom UI widgets that can be reused through different apps. And I don't believe this is the domain from Kotlin native. Kotlin native is not thought to be doing a common interface for mobile apps. It has a better ecosystem, is more performant, except the compiling time, of course. It can probably combine. If you Google something like a Flutter with Kotlin, there is a couple of blog posts of people that have tried, and they give their experience on this field. As some final words, I think in general it's something that is better. It's something that I would not recommend to jump without any consideration or any sort of precaution about it. I think we need to understand where can we apply this, where does this make sense. One thing that I was doing recently for a client was something that I think it brings immediate value is, for example, when we are connected to a web service, essentially, all the apps are sending a response, a request, and are getting a response, and those objects are the same. We could have, for example, those DTOs and those model in Kotlin native, code them once and compile them for different platforms. So that would solve the problem of, not both of them being updated. We could have this code base centralized, and that's not something that compromises a project too much. That would be one example. Keep versioning in mind. It's hard to justify jumping in something that is not stable, so I would not compromise too much unless there is, this has been officialized by the different actors in our industry. And never compromise 100% of a project. I think right now, Kotlin native in the current status is to do small experiments, get your feedback, see how you feel about it, and see whether this is solving your problem or not. Some further resources, Kotlin Slack, if you are not there, you should be as Android developers. There is the entire all the JetBrains team, many people from Google. You can discuss things with them. Touchlab resources, if you came to their GitHub or Google for them, they have a Twitter account or a blog where they write all their learnings about this. If you allow me some spam, in the Kotlin Weekly, more and more, we are including more articles about Kotlin native, and I think it's getting more attention. And of course, the documentation. It's relatively updated and relatively easy to read through, and they have their own Git repository as well with some examples. So, yeah, I think that has been everything. Thanks for being a fantastic public, and if you have any question, I would be more than happy to answer if I can provide an answer.